Namaste, Jai Hind, Vande Mataram. This is Kunal Mehta from Make Me Scientific, and in this video lecture we are going to deal with the equations related to the frequency, wavelength and speed in case of the organ pipes which are open at both the ends. So, here we have the pipe which is open at both the ends having the length same, and what we are going to do is we are going to excite the air column which is inside, we are going to resonate the air column inside, we are going to forcefully make all the air particles oscillate inside with the frequency of the tuning fork having frequency F1. So, the waves are partially going to reflect back from the open end, and the newly formed waves, the sound waves, the longitudinal waves are going to superimpose with the reflected waves, thereby forming the standing waves. But we do know the fact that at the open ends always antinodes are formed. So, we will have two antinodes, and the first possibility, it is basically a concept of drawing. So, the first possibility would be something like this. The antinodes will be at, I should be drawing it more clearly. So, like this. Okay. So, here we have the wavelength as lambda 1, the frequency of the waves is same as the frequency of the source, that is the tuning fork. Now, if we want the another possibility, that means you should have two antinodes over here, but the next possibility will be two antinodes and then one loop at the middle part. You can see that in the first diagram there are no loops, then one loop, then two loops and so on. So, I should be drawing something like this. This is the second possibility, and you can very well see that there is one loop, and the third possibility with the third tuning fork will be two loops. So, it is more better to draw two loops first. This is what I say, you may go according to whatever that suits you, like this, like this, like this one and like this one. So, the diagram was not very good. Let me draw it. So, let us look at the third possibility wherein you will be having two loops in the middle part. So, here an antinode like this, and then one loop, two loop and the antinode. So, here the wavelength was lambda 2, wavelength is lambda 3, all fitting in the same length. So, the length of the pipe in all the three cases is the same. Now, if you look at all the three diagrams, you will immediately come to know that the wavelength in this is case A, this is case B, this is case C. Now, the wavelength keeps on decreasing, right. You can see that the first wave is very long, the second wave is little bit shorter, and the third wave is little bit more compressed compared to the other waves. So, as we go down, the frequency increases and the wavelength decreases. Why? Because in all the three cases the loud sound is heard at the antinode. So, which means that the sound produced has speed v in all the cases, that is because of the fact that the medium in all the cases is the same. So, if I say the wavelength lambda 1, the wavelength lambda 1 is equal to, this is 1/4 of the wavelength, another 1/4 of the wavelength. So, basically half of the wavelength is being fit inside the length L1. So, if I write lambda 1, that is twice the length. Okay. And if I write the frequency, so frequency times the wavelength, that is equal to speed. So, I can also write down frequency is equal to v upon lambda 1, and lambda 1 is 2L. So, this is my first equation. Now, in case of this one, this is 1/4 of the wavelength, this is half of the wavelength, this is 1/4 of the wavelength. So, we have one complete wavelength. So, lambda 2 is basically equal to the length. So, one complete wave is getting fit inside the complete length. Okay. So, I should be writing this as lambda 2 that is equal to 2L by 2, because I want to maintain a pattern. If you look carefully, it is 2L by 1, this is 2L by 2. So, in the next case it will be 2L by 3. Okay. So, the frequency over here F2 that is equal to wavelength, speed divided by wavelength, and wavelength is 2L by 2. So, this 2 goes up. So, this is twice of V by 2L, that can be written as twice the frequency of the first one. So, frequency of the first is F1. So, this is twice the fundamental frequency, twice the first possibility. So, basically this case is second harmonic and this one is the first harmonic. In the same way, let us understand in case of the third part. Now, here this is one complete wavelength from here to here. This is, look, from here till here you have one complete wavelength. Let me highlight it. This is one complete wavelength. Okay, let me use another color. One complete wavelength, and this is 1/4 and 1/4 again. So, that means we now have one full wave and 1/4 1/4. So, one half wave. So, I should be saying 1.5 wavelength lambda 3 is being fit inside the length. This can be written as 3 by 2 lambda 3, that is equal to L. So, we can also say that lambda 3 that is equal to 2L by 3. So, if you look at the pattern, it is 2L by 1, 2L by 2, 2L by 3. Okay. Now, the frequency relationship, that is frequency F3, that is equal to V divided by the wavelength, that is 2L by 3 goes up. So, this is basically 3 times V upon 2L. So, this is equal to 3 times the frequency of the first harmonic. So, basically this is the third harmonic. And if I want to sum up that, the nth harmonic will be having frequency Fn, that will be equal to third harmonic thrice the frequency. So, nth the fundamental frequency. So, this is equal to n f n times the frequency, or in terms of the first frequency you can also write down this as n v by 2L. Writing the equation for the wavelength of the nth harmonic, that will be equal to 2L by n, correct, where n is the nth possibility or the nth harmonic. Now, in terms of the overtones, it is always confusing for the student. So, let us talk about the first one. The first harmonic does not have any loop. So, it is known as zeroth overtone. The second harmonic has one loop. So, I should be calling this as first overtone. In the language of music, by the way, the third harmonic has 2 loops. So, second overtone. In the same way, nth harmonic will be having one loop less. Third harmonic 2 loops, second harmonic 1 loop. So, nth harmonic is basically n minus 1th overtone. And you can very well see that all harmonics are possible. So, if I write the ratio of the frequencies, F1 is to F2 is to F3 dot 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 is to Fn, the answer turns out to be 1 is to 2 is to 3 is to dot 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 till the end. So, this is how the organ pipe is being taken care of.